Right. Welcome back to the show. It's day 11, so let's get started. Okay, we have a cavern full of octopuses. Each octopus gains energy over time and flashes when its energy is full. Okay, so we're measuring the energy level of each octopus. Take that. It's a value between 0 and 9. Here, the top left octopus has an energy level of 5. Right. Model the energy levels in steps. During a single step, the energy increases by 1. Any octopus with an energy level greater than 9 flashes. Um, if this causes an octopus to have an energy level greater than 9, it also flashes. Oh, wait. This increases the energy level of all adjacent octopuses by 1. Okay. Okay. Diagonally adjacent. I see. So it's all 8 octopuses around. Consider this one right. That octopus flashes. An octopus is highlighted when it flashed, right? Okay, so all of these octopuses flash. Oh my goodness. Okay, after step 10, there have been 204 flashes. How many total flashes have there been after 100 steps? Oh my goodness. Okay. So, I think we might want to reuse some of our code from day 9, I want to say. Yeah, where we were looking this stuff up. So first of all, this stuff will still be true. So let's take that. Okay, so we are able to create our grid. And then what else do we need? We need get neighbors. And we're gonna have a few more neighbors than we did before, because it's also going to include the diagonals. So let's see. X minus 1, y. We also need y minus 1, x minus 1, y plus 1, x plus 1, x plus 1, y minus 1, and x plus 1, y plus 1. Okay, and that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So those are all the neighbors. We're going to need this, we're going to need get size and inbounds again also, because we're going to be, like, propagating outside. Yes. Okay. So that's fine. And then I think we want to do step. And so that's going to take an input, and it's going to return an input and an int. So step, given, let's see, we're going to take the current state, return the next state, and the number of times, number of flashes. Oops. Number of flashes. Okay. So what do we need to do? Copilot is trying. I don't think it's gonna know how to do this. Yeah, we're not gonna even look at that. The energy level of each octopus is a value between 0 and 9. Okay. So what we should do is we should write flash. Flash, input position int. So it'll take an input and a position and return an input. An octopus can only flash at most once per step. So the other thing we're going to need to do is keep track of which octopuses flashed so that they don't flash again. Wow, there's so much to keep track of. Okay. So, input, I think we're gonna need sets again. So let's get a set. Set. Flash. So let's take a input and set of positions. Yes. So flash input has flashed XY. And then So I think when we flash, let's set it to 0, and we'll also add it to this has flashed. We'll also keep track of which ones have flashed and reset that as we go. So that way the ones will be 0 once we're done. So get neighbors. So let's also have like a set at. So let's have set at modify at. It'll take the input. I guess it should take a position and a function from int to int. Yes. Can we do that? Width, height. I think we can assume that our position's in bound. So this is going to be new value. Right, new value at that point. We get the new row, we get the new input. I think that's fine. I don't think we need this. Right? We don't. So let's do x, y. Yeah, this is fine. Yes. Right? X is row. Wait a minute. X is row. Let's just double check. So it's not gonna works right now. What else is wrong? This is wrong. Okay, AC debug test. So we've got our input. So let's try and modify at 0, 0. And then let's do const 10 input index too large. What's too large? If I add this. I don't really love how this is. Let's write a list mod at, and it will take an A, and it will take, let's see, we'll take a position. We should take the order doesn't really matter. So let's take a position, and let's take a function. Let's take a list, and we'll return a new list. I think that is right. So this is going to be list mod at y, list mod at xf. Yes, that's better. Okay. That makes me feel better. So let's try one more time. Input modify at. So modify at 0, 0, const 10, input. Okay, so we set the first one to 10. And so what if we do 0, 1? That should set is that right? Is that right to I'm just getting mixed up literally with my like x and y. 5, 4, 8, 0, 1. I think that should be the other way around. X, Y. So first row, fourth, sure. And then what if we do fourth row or fifth row first? Nothing, 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 nothing. 10 is on this row. Okay, that's right. Yeah, that's what we're expecting. So let's just make sure that this, oops. Let's do, oh, we don't even have a get at. Well, let's just make sure. So it should be this and then hello, input, and then we want at. Well, this is going to be at 4 at 0, right? So it's going to be. I think that's fine. I think that seems like a very reasonable way to index into these. So width, get size. So this should be height. Why am I having such a hard time with my x and y today? That's like not even, shouldn't even be difficult. I just want to add spaces to this. That's annoying me. Oh my goodness. Okay. So let's call a position x. Yeah, right? X, Y. Okay, so this was right before, so Copilot knew what it was doing. Y, X. Get at position, input int, yes. Okay, that's fine. That is fine. Now what we need to do is we need to let positions to flash. Set yes. No, it's just gonna be from list get neighbors position. No, X, Y. I think we could just call this pause. But we also need to filter inbounds. Inbounds input. Input. Filter inbounds. Let's do that now. So this will be the set of the positions that are inbound. So this will just be, this is neighbors. Unflashed neighbors. Yes. And then for each of the neighbors, what we need to do, so what we're going to do is it's going to be in, and then we just need to fold fold, let's do a hole. I'm so bad at like these folds. Fold L, fold L. That takes a function. yet. And then it's going to be set.toList unflashed papers. And B is going to be input. So what is type A? Wingman. Interesting. So it's going to be an input. It's going to return input and a position. And what we're going to do is we're going to do modify at position. Position, we want to increase, so it'll be suck. And then input. Yeah. I think we should take these in the other order, because we could actually have this. Yeah, we could do this really nicely. And then we'll take a position and then an input. No, let's take the input and then the position. So this is going to take F, I, and then X and Y, I. This is just going to all be replaced with modify at suck. Beautiful. That's nice. I think that turned out nicely. And then I guess I always end up mixing like lets and wheres, and there's not really a good reason to do that. No. Inbounds. Bounds input. Okay. So we did all that. Can I get these on like, I kind of prefer writing them like this. Oh, okay, that's fine. So I think flash is correct. I think this is going to, I mean, this is just flashing in a single spot. So then what we need to do is, let's define our step. And step input is going to be step input 0. And step input flashes. And we also need the flashed so far. Flashed so far. It'll take an input and an int. And we don't need this int because it can just be the length of our set. Set position. It's going to return an input and an int. Yes. So what we need to do is we need to get the positions to flash. So let's, this is like not a very efficient way to do this, but let's just, all positions. Give me them all. Yes. Perfect. Yeah, that's fine. So all we want is we want the first position that has a, like something to flash. So let positions to flash is going to be and we'll have to take out the ones we've already flashed. So set.fromList. No, we won't, because the ones we've already flashed are, no, they're not necessarily going to be back to 0. So we are going to want to filter, okay. Filter p, get at p input is greater than or equal to 9. And then it's going to be all positions input. Okay, I'm not ready for all this yet. Positions to flash. Flashable positions. We also need positions to flash. It's going to be yes, and then minus set dot difference. Flashed so far. Positions to flash, and this is all going to be to list. And then all we need to do is in if positions to if null positions to flash, then yes, else undefined for now, because we have more work to do. Why is that wrong? Set dot size flashes flash so far. Flashed so far. Okay, so if we don't have any more spaces to flash because everything is either not over 9 or it's somewhere we've already flashed, then we don't have any more places to flash. Otherwise, let's flash the first one and do it again. So it's going to be step, and then, well, I don't think we want to, I'm kind of worried about like doing this all at a time. So let's just do flash input head positions to flash flashed so far, right? Oh no, if we flash them so far, the position, the value is going to stay as 0. So we actually don't need to do this. We don't need to do this at all. Right? No. But we can fix that in this. So if we're trying to flash a position that we've already flashed, so if set.memberPos has flashed, then input else. So if we already flashed the position we're trying to flash, then there's nothing to do. Otherwise, yes. Flashable positions. So we have our positions that are above 9, so those need flashing. And no, it is true that all these positions are very definitely going to need to flash. So we don't even need this check. Because once we flashed a position, it's going to be 0 and it's going to stay 0, because we're never going to increment it in this. So that's fine. Then let's break this out. Else let what does flash return? Oh, flash just returns an input. Okay, that's fine. Let next input equals flash. Input flash so far head of. This is flashable positions. In step next input, we're going to let flash position head flashable positions flash position next input set dot add set dot insert. Yeah, is that right? I think that's right. I think that's right. Yes. So let's see if we can. So let's see, step input. What did that give us? Did anything change? Let's do a shorter one. Let's do like this one. Well, test. Input. Uh-oh. Okay, don't feel good about that. No. Step, next input. So let's just try flashing on this. Flash, word qualified, set. Flash input D11. So what did that give us? Increased a bunch of those to 2. Yeah. Yeah, so let's keep trying. Flash it. List. 1, 2. Uh-oh. Oh, this is not how that works. So set.fromList. Set.fromList. Okay. 1, 1. 1, 2. Whoops. Need to flash 1, 3. We need to flash 2, 1. Yeah. Need to flash 2, 3. We need to flash 3, 1. 2, 3, 3, 1. We need to flash 3, 2. Oh. Oh, the reason this doesn't work is because we didn't set the position we flashed back to 0. That's it. So modify at suck. And then we also need to do modify at const 0 input. Right? Oh, that takes a heck. Oh, this this just sucks because there's I after incrementing neighbors in modify at const 0 after incrementing neighbors pause. That's it. That's what we need. Okay. So let's try just running again. Perfect. So that looks good, and I think we did 9. We didn't indeed do 9 flashes, and on the top, no. That seems, oh no. After step 1, shouldn't it be 3, 4, 5, 4, 3? Oh no. Why are our numbers not big enough? This increases, right? So let's just try step 0, 0, 0, 0, 9, 0, 0, 0, 0. So that is right. So if we have 9, 9, 9. Is that right? Yeah, that's right. So why was this wrong? Input. Step input. Wait, hang on. This doesn't seem right, does it? Why is this 3? What? Am I hmm. Am I missing something? This doesn't make sense to me. But let's try it with this test input. Debug test. Wait a minute. Input 5483. Oh, because everything else needs to increment. Right. First, the energy level of each octopus increases by 1. So let's do that first. So the first thing we need to do in the step is input equals map suck input. And then we'll use input prime here. And then I think we also need to do that here and here. Okay, let's try that. Step input. That's why this increased. So let's double check. So test AOC debug test step input. Oh no. Oh, because we shouldn't do that in every step. We should be doing that here. Let input is step is map. We can just do it here. Step map suck. We don't do that here. Okay, we shouldn't do that for every single one. Oh gosh, that will never end. Okay, so stop you, reload that. 34543. Yes, and then 45654 51115. Perfect. Okay, I think we're ready to try this sample again. So let's do step input. No. Oh, it has to be larger than 9, it looks like. Okay. 659, yep. Step first of it. Is this 35 things that stepped? I guess it is. It seems like we all have lots of zeros. 7, 4, 5, 6. 9's 8, 7, 6. That seems to match. Let's try one more. Class line 0, 0, 2, 1, 1, 1, 9, 0, 0, 0. Okay, I think that's okay. So all we need to do now is step 100 times. So, do n steps. It's going to take an int and an input, and it's going to return an int. Do n steps and return the total number of flashes. You do it? I don't think that's right. So let's just do n steps 0. Oh no, do n steps equals do n steps prime, and we'll start with 0. So do n steps. This shouldn't be n. This should be flashes. And 0 flashes. And input is going to be next input flashes equals step input. in do n steps, step flashes. Flashes plus step flashes and -1 next input. Okay, I think that's right. So let's write do n steps 100. Test 1656. Yes. Okay, we made it happen. I really hope that part 2 just is asking us to do more steps, because we can definitely do that. But I'm sure it'll be something hard instead. 1637. Oh, this is a pretty small board. So that's right. It seems like the individual flashes aren't bright enough to navigate. However, the flashes are synchronizing. So after step 195, they all will flash. What is the first step during which all octopuses flash? Okay. Get synchronized flash step. We'll take input and return an int. Return the first step in which all octopuses flash. Can it do it? No. So this is just going to be go 0, 1. We'll start at 1. I think this is right. If we're off by 1, we'll fix it. So if flashes is input, because let's get width 8 is that cells width times height. So if that equals cells, then it's n. So let's try that. Let's try test 8. No. Because we should define it. Get synchronized flash step. 195? Is that right? 195, yes. 242. We did it! Okay. Well, that second part was really straightforward, thankfully, after solving the first step. So that wasn't too bad. It was definitely pretty tricky just at the beginning thinking about how we wanted to do this. But I think just flashing one at a time and doing the recursion that way seemed to work out okay. Fairly similar to how I sort of approached the that one on day 9 where we were filling in the basin. And then just also using a set to keep track of which places we'd already flashed so we didn't flash them again. Yeah, I think there's definitely a better way to do this. Probably it feels kind of wrong to be... Well, actually, I guess that's not that bad, because this is lazy, right? And we're only checking if it's null or getting the first one. So we don't need to actually check all the positions. We're basically just finding the first position that is over 9. But that definitely could be optimized down a little bit. I guess we could pass, like we could consume from all positions, and like only keep going from the remaining part of all positions. I'm not sure we need like another argument into this step function, I think. So that might speed it up a little bit, but ultimately I was kind of surprised by how small this grid was, and it ran pretty quick. So I think we did a decent job today. I feel pretty good, especially about part B, went quickly. So that's gonna be it. Thanks for watching, and I'll see you tomorrow.